Machine learning engineers are currently pulling in starting salaries between $150,000 and $200,000 a year. But most people who try to learn the skills to land those roles end up quitting. They don't quit because the concepts are too hard. They quit because they spend months studying the wrong things. The most common failure point is starting with theory. Beginners often try to learn every prerequisite before they build anything. They drown in theoretical math proofs and memorize massive textbooks without ever training a single model or typing code into their machine. To avoid this, you need to apply the 70-30 rule. You must spend 70% of your time doing hands-on coding, making mistakes, and building projects. Only 30% should go toward reading theory and watching tutorials. To go from zero to deploying a working model in 6 months, you have to lean on existing tools. You will learn faster by attempting to build something first, identifying where your knowledge is lacking, and then specifically backfilling the theory you need to solve that problem. This timeline breaks down exactly how to spend your next 6 months. For weeks 1 through 4, focus entirely on Python. Skip other languages like Julia or R for now. Python is the foundation you need before looking at any math or theory. This diagram outlines the mechanics you need to be comfortable with. We are talking about variables, loops, functions, and file handling. You also need to understand data structures, specifically how to use lists, sets, and dictionaries to organize information. Once you know the basic syntax, you will add 3 essential Python libraries. First is NumPy, which handles arrays and background math. Next is Pandas, which you will use to manipulate large datasets. Finally, Matplotlib will let you visualize that data with plots and graphs. You do not need to be an expert in any of these yet. Your only goal for month 1 is to be able to read a basic CSV file, manipulate a data frame, and output a simple visual plot. This visualization represents the math requirements for weeks 5 and 6. You will need to review linear algebra basics like vectors and dot products, then probability and statistics, covering distributions and Bayes' theorem. Finally, basic calculus, specifically derivatives and integrals. As we strip away the proofs, the math requirements change. You need to understand the concept of a derivative or a gradient, but you do not need to manually derive them from scratch. As long as you know why a concept works at a high level, you can select the correct algorithm for your problem. This keeps your momentum going and prevents you from getting stuck for weeks trying to manually solve equations. Moving into months 2 and 3, you will start building core machine learning models. Your primary tool here is scikit-learn, a Python library with great documentation, designed specifically for these classical algorithms. The first category you will tackle is supervised learning. Think of it like this machine taking raw, chaotic inputs and sorting them into clearly defined outcome pathways based on existing labels. You need to practice writing and training supervised models like linear regression, decision trees, and random forests. Then you will move to unsupervised learning, where the data has no labels, using techniques like k-means clustering to find hidden patterns. Building a model means nothing if you cannot evaluate it. You have to understand metrics like accuracy, precision, and recall. You will also learn cross-validation to prove your model actually works on data it hasn't seen before. Success in this phase looks like predicting housing prices or classifying emails using real datasets. You are officially shifting from randomly typing tutorials to targeted problem solving. For months 4 and 5, you will add neural networks. While TensorFlow is still out there, PyTorch is the modern industry standard, dominating both research and production environments. This diagram shows the flow of a neural network. You will start by building out neurons and layers. Then you will learn how activation functions trigger the pathways and how loss functions and backpropagation optimize the network's accuracy. Once you understand the base layer, you can look at specialized architectures. You will use convolutional neural networks, or CNNs, to classify images. Then you will study transformers, which are the architecture driving every modern large language model today. You do not need to build a massive language model from scratch on day 1. Instead, a highly practical step is pulling a pre-trained model from a repository like Hugging Face and then fine-tuning it with your own specific data. Understanding these underlying mechanics allows you to troubleshoot and modify model behavior directly. You are engineering the system's logic, moving beyond the level of a prompt typist. In month 6, you hit the skills that actually lead to hiring. This is the transition from local development into the requirements of cloud deployment and continuous integration infrastructure. This comparison highlights a practical reality. While tutorials provide clean data, 80% of professional machine learning work is cleaning the messy, jagged data on the right, wrestling with missing values and uneven distributions. To get your model out of a notebook, you need to package it so it runs reliably anywhere. You will learn to containerize your work using Docker, and then set up model serving with an inference server like FastAPI. Finally, you have to host it. You will need to pick at least one of the major cloud platforms, AWS, Google Cloud, or Azure, and learn how to deploy your containers to their specific environments. A highly accurate model isolated on your personal laptop has zero practical value to a business. Engineers get hired because they can serve their models in a production environment where actual customers can use them. That is the 6-month technical roadmap. But completing it only brings you to the final hurdle, proving you have those skills to an employer. To do this, you have to learn in public. You need to push your code to GitHub, document your end-to-end projects, and write about the mistakes you made on LinkedIn. In machine learning, recruiters routinely ignore theoretical certifications. They hire based on the visible infrastructure you have built and the models you have actually deployed online. Avoid tutorial purgatory by picking a single structured resource and finishing it completely before jumping to the next. Pick your starting point and begin week 1 right now. This timeline works because it bypasses the friction of traditional academia. By forcing yourself to build first and learn the theory later, you stop being a passive consumer and permanently become a capable, hireable builder.